Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Electronics and Telecommunication Department in Government Engineering College, Bilaspur, Chhattisgarh. And in this video lecture series, I am teaching Signals and System for upcoming GATE examination, and it will also cover engineering service examination also. So till then, this is the 9th lecture, and I have completed 8 lectures on it. And we have understood many type of elementary signals, and how we can do some operations like time shifting, scaling, and reversal, and all operations on it. Differentiation of signals, integration of signals, we have performed it and we have seen it how we can do it. And then classification of signals, we in the last lecture we have seen the even and odd signal, and energy and power signal. Now in this video lecture series, in this video lecture, 9th lecture, I will be dealing with some other signal apart from these many signals, like random or and deterministic signal, causal or non-causal signal, and analog and digital signal. So let's get started with our first portion, that is random and deterministic signal. Okay, fine. So what are these type of signal? See, the name suggests random signal, the signal which is having some random values, and we cannot predict it. That is called as random signal. And deterministic signal means determined, means which can be determined by some mathematical equation. Means a signal which follows some mathematical equation, in which if we put some value, we can predict what value it will be generated. Okay, that is deterministic signal. So we can write here signals. Okay, signals which can be defined by well-defined expression. Okay, signals which can be defined by well-defined expression, that signals are called as deterministic signal. Okay, so that signals are called as deterministic signals. Like, I'll tell you some example. Okay, we'll take some example like ft is given for you. Let's suppose 2t plus 3 is given. Okay, so 2t plus 3, if you can calculate for f t is equal to 0, you will get as 2 into 0 plus 3 equal to 3. So some value is given at t is equal to 0, we know. Let's suppose f of 2 we need. So we'll take 2 into 2, 4, plus 3, 7. So some values are given, means at any time instant you can predict what value will come. So this type of signal will be called as deterministic signal, which are defined by a well-defined equation, well-defined mathematical expression. That signal are called as deterministic signal. And signal whose future value cannot be realized exactly, okay, staying at staying at present time, that signals are called random signal. Means such signals does not have a proper mathematical expression, and so because of that we cannot predict some values. So these signals are very easy in, you can directly understand which are random and which are deterministic signal. Okay, so let's suppose see, this value is there. I think maybe some like this signal is there. Now if this signal cannot be explained by some any mathematical expression, so this signal will be called as random signal. And see, this signal is like this signal is there. This can be represented as ft is equal to sine of t, let's suppose. So this is the proper equation is there, mathematical expression is there, in which at remaining at present time you can predict some future value. That signals are called as deterministic signal. Simple concept is there. Okay, next portion will deal with causal and non-causal signal. This is also very important part. See, causal and non-causal signal are those signals. See, one signal is there, let's suppose this signal is there, like this, like this, like this signal is there, and so on, it is given. And one type of signal ut, you know, which will exist after t is greater than 0. So those signal whose values are equal to 0 for t is less than 0, those signals are called as causal signal. Remember it. Okay, so just need to remember those signal whose values are equal to 0, which value doesn't exist at t is less than 0, those signals are definitely called as causal signal. Okay, and some signals like this type of signal whose values are defined at t is less than 0, these type of signals are called as non causal signal. Okay, so only this much is there. If mathematically, if I'll write ft is equal to 0 for t is less than 0, this signal are called as causal signal. And when ft is not equal to 0 for t is greater than 0, it is called as non causal signal. Okay, now I'll tell you what are bounded signal and unbounded signal. So next we'll see as bounded and unbounded signal. Okay, bounded and unbounded signals are which type? See, bounded means not of time bounded, it is actually of amplitude bounded. I am speaking about amplitude bounded. So how it will look like? See, uh, this is there, this is our time axis, this is our amplitude axis, and any signal is there, let's suppose this signal is there. Okay, so you can see its amplitude is bounded between this value. Okay, and let's see one more signal is there, t, and this is your amplitude, and one more signal will say, see this type of signal. Okay, this is not amplitude bounded. So bounded signal means which is defined for a fixed amplitude. Okay, and for this which is not defined for a fixed amplitude, that is called unbounded signal. So the bounded or unbounded means your amplitude boundation will be there. So see, if mod of ft means ft magnitude is less than or equal to finite. Okay, is less than or equal to finite, this signal will be called as bounded signal. Okay, and if ft mod of ft is equal to infinite value, then it is unbounded signals. This very easy concept. Okay, and one more, left sided signal, right sided signal also will deal with this also. See, one is left sided and right sided signal. Okay, so what are left sided? See, some signals are like this, so are called as left sided signal. Some signals are like this. Okay, these signals are called as right sided signal, and some signals are like this, like signum t is there. Okay, like e to the power e to the power minus a mod t is there. So these type of signal are double sided signal. These type of signal are called as double sided signal or two sided signal. So left sided signal I have understood, I told you, right sided signal also, and double sided signal also. So now let's start with our next type of signal, that is called as analog or and digital signals. And this will be the last topic in signals part. So analog and digital signals. Okay, fine. So what are analog and digital signals when we see? Okay, so let's talk about this type of signal. Analog and digital, actually, see, earlier we have already talked about continuous time signal and discrete time signal. You have already understood that whenever time axis, in time axis, the signal, every value exists at every time instant, that is called continuous time signal. And in time axis, when a signal is exist only for a set of integers value, for an integer number only, then that signals are called as discrete time signal. Okay, so this we have understood earlier. Now, but earlier we used to talk about x-axis only, time axis only. We haven't talked about amplitude axis. So now we'll talk about amplitude axis, and there we'll classify as analog and digital signal. So see, this is the time axis and this is your amplitude axis. So if any signal is there, which is defined for every amplitude, any amplitude, it is defined with any values, then it is called as analog signal. Simple. Analog signal means the signal which is defined for any amplitude, that signal is called as analog signal. And digital signals are those type of signals, like see, this type of signals are there. This is our time axis and this is our amplitude axis. So if a signal is defined for a particular level, only two values are there, let's suppose this. So we'll see this value is there. So it is defined as for only this much value, and then it is defined, and let's suppose for this value this is defined. Okay, so this this type of signal which is defined for only limited number of amplitude, exactly two amplitudes, then this type of signals are called as digital signal. Simple concept. If a signal is in its dynamic range is allowed to consider all possible real values, is called as analog signal. And if a signal is allowed to consider only some specific values, in its dynamic range, it is called as digital signal. Normal concept is there, nothing is there. So always we say like this type of signal, it is called as digital signal because it is taking only two amplitudes. But same thing, if it is occurring like this, it is taking every amplitude. Okay, every amplitude it is taking, so it is called as analog signal. This is called as digital signal. So now if we mix continuous time, I will tell you some values, like see, continuous time, है ना? Analog signal, if I will say you plot it, then if I will tell you continuous time digital signal, and then discrete time analog signal, and discrete time digital signal, if it is to be plotted, then how we can plot it? See, this will be continuous time and analog signal. So time will be in continuous, every value can be taken in time, and every value can be taken in our amplitude also. So here we can write it down as like this signal. This is continuous time analog signal. Okay, now we'll see another signal like this type of signal. So this value is there. Here we will take continuous time, means every time value we can take, but amplitude we can take only discrete, digital. So only two values we can take. So like this we'll take like this, values will be there, and then we'll take like this value, and almost like this values are there, this type of signals are called as continuous time digital signal, because this is continuous and only values are specific values are to be taken. Okay, now we'll take as discrete time. Now time is discrete and analog, amplitude is analog. Okay, so now we'll take it as, see, this is discrete and analog. Any values can be taken, okay, so this type of signal is called as discrete time, but analog signal is there. Okay, and last but not the least, discrete time digital signal, what we can take, here it is time, here it is amplitude, and we can take, see, discrete time means samples will be there, and digital means only specific amplitude will be taken. So this will be there, this will be there, this will be there, this will be there, this will be there. Only two amplitudes are taken in this, some specific values are taken, and signals here it is defined for n is equal to 1, 2, 3, 4, 5, only integer values are there. So this is called as discrete time digital signal. So I think you can plot it, and you can understand that how analog signal and digital signals are working, and these all are some basic classification of signals. So here we end our signals part, classification of signals part. In next lecture we will deal with systems, and we'll deal with what are the properties of system, what are the classification of systems and all. So for this lecture this much only. We'll meet in the next lecture. Till then, tata, bye bye, see you, have a good day, jai hind, jai bharat. Okay, so